Systems Division, Mitsubishi Electric. His experience as a user, manufacturer, and sales marketer of automation equipments. He started as a mechanical engineer designing high-torque gearboxes. He then entered system integration before joining ME in a variety of roles from support to marketing in UK, Germany, and Japan, where he now has a global responsibility for marketing communication. Please welcome him on the stage.
I'm going to talk about something different this afternoon. I'm going to talk about AI in manufacturing. I think you've heard about AI from other people in past forums, but I'm going to give this a 360-degree look, something a little bit different. Actually ties in very closely with what Sal was talking about, which is the human element, which we need to consider very deeply when we're thinking about such new technologies. I'm also a little bit nervous, but I'm very happy to see there are not too many bottles of water on the table, because yesterday, one of the co-founders of Baidu, a guy called Robin Lee, he was making a presentation about AI, and some very excited audience member jumped up and tipped a bottle of water over him. And he said, as you can see, all kinds of unexpected things happen on our way in the journey to develop AI, which the audience seemed to appreciate quite a lot. But I'm sure that his wet shirt wasn't appreciated by him. So let's start with some of the favorite things of marketeers, and that's some statistics. Because, you know, there's lies, damn lies, and statistics. We can make anything out of anything. But the interesting thing is, if we look at this particular report, you can see it highlighted in the top corner. You can see that there's actually a comparison between what the general public understand and what the so-called experts understand as being where AI is used and what technologies use AI. And the interesting thing is that the general public's knowledge and the experts' knowledge is not so different. That's quite encouraging, quite encouraging. And, you know, they're identifying areas that are, okay, pretty obvious. Perhaps voice recognition and natural learning processes and perhaps robot teaching as being AI applications. When we look at the technologies used by AI, then it gets a little bit more nervous because the experts seem to think that the world robotics are using AI, of course, but machine learning is not actually using AI. Machine learning is a subset of AI as a way of training AI to do what you want. So it's a little bit nervous making that they're thinking it's a technology used. Anyway, let's investigate that a little bit further. So just adding AI, it's not like just adding some salt and pepper to something and then everything magically changes and everything is able to be proceeded in the way that you thought would happen. To be honest, it's a lot more complicated. If we take the example of a robot, because Industry 4.0, everything you see, there's an icon of a robot somewhere. So let's use that as our icon for AI as well. So on this robot, we've got issues to do with gripper, how to pick things, how much pressure to apply, how to actually orientate myself to actually pick the thing in the right way. I've got no senses. I'm stupid, a robot. So humans have got the 5 senses, the smell, the touch, the taste, the hearing. So we need to give the robot some senses to understand its environment. So we need to give it some vision. Then we need to interpret that vision into something so the robot can understand that and actually do something with that information. And of course, we have positioning as well. Where is the robot moving to and what does it have to avoid? Other things inside the operation cell. And we may make a digital twin and do some simulation, which might have some interesting insights we need to move. Then we have movement paths. What happens if the human comes into the way of the robot when it's moving? What should we do? Should we hit him, or shall we just stop, or shall we go around him? A lot of considerations. And guess what? One AI is not going to solve all of them. You're going to need specialist applications for each area. And again, we'll touch that later. Guess what? There's not one AI. There's lots of AIs. There's wonderful different ways of looking at things. And you've got swarm intelligence and combinatorial explosion and adversarial AIs, where you have two AIs fighting each other, trying to work out what is the best result to apply in the future. So all of this AI is different mathematical ways of looking at data, looking at information, and it's all trying to mimic what we've been doing for 2,000 years. Applying common sense, applying our senses to the situation, and making snap decisions. It's got to do that instantly by itself with no additional support. Pretty tough challenge. And guess what? Just like humans, it's not infallible. And there are a couple of notable examples that we've seen recently. 23rd of March, 2016, very famous for Microsoft. Anybody know Tay? No? Tay was a chatbot that Microsoft put onto the internet, and within 16 hours had made 96,000 tweets, which were highly politically incorrect, racist even, and sexist, because some rather naughty web browsing people had seen it and started to teach the AI things that it shouldn't teach. And guess what? AI is not clever enough to identify the difference between good and bad, right and wrong. It just receives the information and says, okay, I'm learning, and then it starts repeating it back to the market. And you end up with an embarrassment factor. So, guess what Microsoft did? Off. So we didn't hear any more from Tay for a while. A little bit more seriously, you probably know of the issues from Boeing with the MAX 8s. And some people are reporting that maybe there's some confusion inside the system, the control mechanism, the AIs that they're using, where they're conflicting information or lack of information coming from only one sensor that's giving false scenarios and then creating actions based on that. Sometimes things don't go so well. Even the most famous of AIs, the Watson, the IBM Watson, one of the most original cloud-based AIs that were released, they are also having to step back occasionally and having a rethink about what are we doing, how are we doing it. This example is from the pharma industry, and basically they started to misdiagnose cancer patients. Now, I'm not saying these guys are bad. What I'm saying is this will get better. This is natural. Remember when the cars first came out in 1918 or earlier, and one of the things that happened perhaps in Europe, I'm not sure about other countries, there was a man with a red flag walking in front of the car to say, be careful, there's a car coming. Well, we're kind of at that very embryonic stage with the AI activity. Be careful, there's AI coming. So we're going to have to be, a little bit cautious about how we apply this. But it will revolutionize our manufacturing processes and our lives. So don't be scared. Yes, mistakes happen, but we're humans, we make mistakes, we learn, it learns, things move on. The thing is, the more complex the situation you try to feed into this AI, the more chance for mistakes are going to happen, the more compute power you need, the longer you need to process data before you even get a result set that you can use to model things with, the more energy for the computers you need to put in, more training of the AI, the more data and inputs. So basically, complexity equals a longer time to reach stability. That's why there will not be one universal AI controlling everything. Don't worry, Arnold Schwarzenegger is not going to be fighting the robots for you, because they're not going to be coming at least for the next couple of 100 years. So you're safe. Let's go back to our robot, and let's think about one particular area, vision. We see a lot about vision being something that can be used, facial recognition and all this kind of stuff. And let's think about this in a manufacturing context. I want to show you my video. That's amazing, isn't it? You thought that was a real egg, didn't you? I know the first time I saw that, I thought that was the real egg. And then guess what? When a robot's looking at a situation with a vision system, it can easily also be confused or tricked into actually which is the real scenario. So actually, this rather light-hearted video is a good way of explaining to you how hard it is to actually look at something. Without 3D vision, you can't measure depth. And then once you have a situation where you have lots of things close to each other, you can't distinguish which is which. So it's a challenge for us. So let's think of AI as less as something that's going to kind of solve every problem for us, but as something that's going to enhance our performance and our manufacturing activity. It's a support tool for us. It's a way of giving us the predictive maintenance. It's a way of actually giving us the best computation for the path that we want to follow. It's a way of understanding the force feedback from the wrist of the robot and its gripper. It's a way of interacting with the human so that he can interact with the robot in a better way. So I said I was going to look at this in a 360 way. So we've looked at some of the technological issues. Now let's look at some of the social issues. I already mentioned that AI basically doesn't understand the difference between right and wrong. It's completely agnostic. The other kind of issue that derives from that is then something you're hearing about with the self-driving cars, which is who has the legal responsibility for when it goes wrong? You know, is it the guy who created the AI algorithm, or is it the guy who put it in the car, or is it the person who should have had their hands on the steering wheel to supplement the AI situation? Well, it's completely unclear, and actually this is an interesting spin-off from the digitalization discussion because we've got another digitalization impact happening here. The car example is something we can relate to. Go to a manufacturing example and we damage a person in the factory floor, or we get some statistics wrong and we suddenly end up with a big hole in the ground where there used to be a plant. Who's going to take responsibility? Oh, it wasn't me. The AI was working perfectly well. Interesting. So it's got the potential also to create and destroy jobs. That's a situation with most things that we've experienced over the period that manufacturing has actually grown. And it's also, this is probably a little bit related to the Boeing scenario where, you know, what happens when you have a runaway event? Who has the master switch to stop it? When do you stop it? How do you stop it safely? These are the things that also come out. And the ownership of data, I think, will also be an interesting discussion that will come up in the future. Of course, you're all aware of the Facebook scenario and Cambridge Analytics taking data and understanding people and so-called manipulating election scenarios. Now, imagine that these guys are coming on to your factory floor and saying, right, I'm going to collect the data for you and I'm going to give you some results back. But then they also use that data for other purposes which you didn't expect. Now, when we talk to manufacturers about technology, about clouds, and maybe we just seem to be unlucky and talk to all the conservative manufacturers, but seems to me there's a common theme here, which is they get rather nervous when they start talking about taking the data off-site and out of their control. You explain to them that it's still within their ownership, it's their data, nobody else is going to have access to it, but they still get nervous because that's their IP. Remember, the Coca-Cola company has a recipe for Coca-Cola which is known by about 4 people around the world, but not all of them have the whole recipe. That's how nervous these guys get. And one other thing I'd like to just kind of touch on, which is that AI does everything by itself. No need to program it. Wrong. Actually, there's a new can't even speak, a new word for programming for AI, and basically that actually means you're training it. So when you think about some of the AI applications, especially when you're using image manipulation, you need to feed thousands and thousands and thousands, tens of thousands of images into the system before it's fully trained. Another interesting scenario recently was IBM used the photos in, I think it was WhatsApp and Facebook together, and took all those images without people's permission to train their facial recognition system. Everybody's, oh no, privacy. But it explains how much data you need to make this reality. That's why, again, the idea of having ubiquitous AI that does everything, unless you've got a server the size of this room, is not going to happen. United Nations, 2018, they made a significant announcement. I don't suppose any of you were actually watching this. Basically, there are more elderly people than children. Now, 705 million people over the age of 65. I'm getting close there. I know I look young, but actually I'm getting to the top end of that. And I'm thinking, they're right. Who's going to replace me in the future? And if I think about China, one of the most populous countries in the world, 10.5% of their population is already over 65. And remember, they had the one-child policy, so they don't have the big imbalance that we will see in other countries. In EU, 19.7, almost 20% of the population are over 65. Mamma mia, in Italy, 23%. And the country where I live, the country where I live is even more frightening, almost 30%. Now, if there's 30% of the population over the age of 65, who's going to pay my pension? Because I'm worried about that. Because as I said, I'm getting close to there. Now, the average life expectancy in Japan is 84 years old. That's the average. That means there's lots of people living over 100. I'm wondering, do you want to have somebody 84 years old servicing your machines? I don't think so. I mean, I need glasses now, and if I'm 84, I'm hobbling around with gout, and if you walking stick coming along, I'm going to fix this for you. It's not on my game. So actually, we need to do something, and we need something to help us to manage this scenario for the future. And, one of the things that, for example, the Japanese government has done is started to recruit more foreign nationals. In the past, to work in Japan, it was really difficult. There was lots of barriers socially and kind of economically to prevent you from coming. Now you're welcome. And guess where most of the people are going? Manufacturing. Now, that's a clue why we're looking at robots and AI, because we need to have some sustainability, because foreign nationals coming to Japan, they're basically economic migrants. They're coming there, they're getting lots of money, then they're going back home again, and they're doing the things they really want to do. So actually, we're not maintaining the status quo here. We're actually kind of just living by the day. So is my job at risk from AI? Because I said it was a force for good and a force for the negative. Well, there was a survey in the US of federal jobs that were at risk from AI by 2030. And you know what? My heart bleeds for the tax examiners. I'm really sorry for them, but they seem to be most at risk. That's a shame. But if we look at is my job being replaced by automation generally around the world, you see a slightly unusual picture. And you'll be thinking, well, why is the UK, US, and maybe more of the modern economies, let's say, a lower figure? Well, that's pretty simple, because those guys have been forced in the past to actually modernize their production because they have to be competitive. That's why you see China having such a large number or risk, the potential of being replaced by AI and robots and automation. Because they have a large populous workforce, there's a lot of manual activity going on. We know from our own activities selling to certain large white goods manufacturers, people making electronics, that their use of robots is exploding. We also know, because we are making robots and we see the market in China, the number of Chinese robot vendors is exploding. So this real picture is really going to be significant for China. They're going to have a problem. They're going to have a lot of people out there who need to have jobs, who are now no longer actually directly working in the manufacturing or manual processing workspace. This is the social impact side. We have the aging workforce, then we have a workforce which we need to redeploy. So we need to think about these things, exactly what Sal said. It's about the culture of change. And I said we'd use robots as a metaphor for the application of AI, and as you can see, the use of robots is going to do nothing except go up. So we can expect the use of AI to do nothing but go up. And we can expect in the future that countries that have a high installed base of robots already, like South Korea or even Singapore, Germany, that those guys are also going to be using more AI in the future as well. Again, back to Japan, there was a survey which asked the Japanese populace, do you agree or disagree whether the use of AI and robots will increase inequality between rich and poor? And the resounding result was they agree. It's going to increase the inequality. And, you know, will it result in more high-paying jobs? They don't believe it's going to result in more high-paying jobs. There is a discussion that there will be a change in the job function. That's probably true. What that actually will be in the future, I can't say. I don't know. But definitely more high-skilled jobs will be coming, but there will be fewer people that will be actually doing those. So that pool will get bigger, but actually as a percentage of the community, it won't be as much as it was in the past for employee manufacturing. So the trend as we see it is that, well, manufacturing every millisecond counts. So we see that, of course, manufacturing needs to react faster. It was identified earlier that the customers, and I mean every single one of you guys, who is going on to Amazon or any of those kind of shopping environments and you're choosing a t-shirt, you're expecting to get that t-shirt delivered in the next 1 or 2 days, and you want not just one color, we're not talking Henry Ford t-shirts here, black only. You're going to want every single color under the rainbow, and you're going to want it arriving in that 2 days. So from the manufacturer's point of view, that's a complete nightmare, because what am I going to stock? What am I actually going to produce to sell to my friends at Amazon to put in their warehouse, that they don't return it to me later and ask for money back? And then there's also the issue, for example, of more technical products where we want traceability, or products with, there's a lot of traceability in pharmaceutical, but there's even more going to be increasing in the future. Aging population issues I mentioned, and the production cost issue. So the overall balance is AI is a force for the future. And we expect it will be envisaged in a bunch of skills, exactly the same kind of feeling you get with your home assistant. You'll have a skill for the weather, and a skill for your music, and a skill for language translation, and all of those will be in a single environment. But they'll come from different vendors, because there'll be different expertise coming in. So kind of the interoperability will move to a new kind of sphere of the world. But we will see that AI exists at every single level. It won't just be these cloud deployments, and it won't just be software deployment. You will see it in components. We ourselves have also recently released hardware devices with AI built in, and they are instantly responding to the situation. You don't have to train them for months or years on end. So this is exactly what's coming. I say it's the future, but it's coming now. So why are we expecting this? Because reaction time, server time, security issues. You know, if you lose connection with your cloud, what are you going to do? Sit around, wait for something to happen? You can't. Your manufacturing's happening, so you need to have that kind of residual resilience inside your system. So we believe the perfect AI is a bit like one of these robotic cleaners. You know, it's something you don't think about. We expect that in the future, you'll be asking, you know, how many times does somebody come up to you and say, I want to buy an IoT, please? And it never happens, does it? So I can't believe that somebody's going to come up and say to you, hey, I'd like to buy an AI. What they want to do is to buy a service. They want to buy something that's going to make their life much better. You know, if I was buying one of these robotic cleaners, it's because I'm too lazy to go around pushing the thing. So that's the reason I buy it. And I want you as a manufacturer to make that the best device possible. So when you're making a manufacturing line in the future, you're going to want components and product parts that do the same function. Some real applications. Okay, hole-in-one. So this is an application of the robot placing something inside a hole. Okay, we've drawn it like this because it just makes it very simple to explain. Traditionally, we would have approached the hole at speed and slowed down a little bit and then pushed into the hole. That's not necessarily the best way, because robots are very accurate in their positioning, But sometimes if you're pushing in, for example, a shaft into a tight bearing, of course, the accuracy is very, very tight. So even 0.001 of a millimeter movement is going to hit the side of the bearing, and you're going to end up with some damage. Okay, how do we overcome that? Well, now what we do is we incorporate a force sensor into the robot wrist, and we apply AI to that, so that actually we move very fast up to the entrance of the bearing, and then we move slowly to ensure that we got the positioning correct, so that we are guided into the hole, and we're getting the feedback from the force sensor, and then we move fast through the hole, and then just before we hit the bottom of the casing, we are already slowing down to make sure that we don't damage the end of the shaft. So this is the difference of what AI does. I've just explained this, but basically it's a PDCA, and we've optimized and modeled already, and then actually we're using the force sensor to come back to make the adjustment on the arm position, and we're applying AI technology to make maximum use of speed. So the results of this is the setup time of this particular operation is reduced by 65%. It's real fact. And we didn't need a cloud because it's based in the robot. It's totally self-optimizing. So once we've set this up with the other 35% of setup time, this is going to run itself because that AI is done specifically to do one specific task. Now I'm going to show you another kind of application in a different kind of manufacturing to do with food. I'm keeping you from your food, I realize that. But this is interesting because it's nothing to do with us. Completely nothing to do with Mitsubishi. Just happens to be one of our partners that did this quite cool thing. So let me just get my mouse over there so I can run the video. This is a nursery. It's where lots of new plants are grown. And it used to employ somewhere between 10 and 12 people, now 2 people. And you can see that the cuttings, the little plants, are dropped onto the conveyor belt. What is more natural in the world than a natural plant? So every one of them is unique and different. So the AI is actually having to recognize the plant, its orientation, and being able to know where to pick it up so that it can actually deposit it into the seed tray to grow for the next generation of plant. And the guy who owns the nursery, he's obviously not an engineer, he's a farmer. And he doesn't want to get on the end of the phone and call somebody when he wants to grow a new type of lettuce or a new kind of small plant. So actually, he has a tablet, and he takes a couple of photos of his new plant cutting. Hey, we're training again. And he's got them on screen, and he draws on his iPad exactly where the robot should pick this particular cutting up. That's it. That's all he's done. Yeah, okay, occasionally the robot's going to squeeze the cutting in the wrong place or whatever, and okay, that one didn't grow, nobody will know. Don't worry about it. But most of the plants will grow. So it's pretty fine. So he's very happy. He's got the right people doing the right job. He's in control of his actual information and his processes. So it's a really interesting view of the future. That says 2 minutes left. Impossible. Let's get on the next. Right. So I talked about vision earlier and some of the big challenges around that. And yes, we've done some vision stuff in the past. And you know, bin picking is one of the golden targets for warehouse management and for manufacturing environments. And you need 3D vision sensors, but it's not enough. So what we've also been working on, and we know other people are doing the same things because it's logical, we're doing bin simulation. So actually, when you tip the components into the bin in the first place, we're simulating how they will fall. So before we even try and pick them up, we've got an idea of where they will be, which orientation they will be, so that it gives us a fighting chance to actually find the thing in the first place. Then we're actually doing some recognition. So if you see the picture on the right-hand side, my right, your left, you can see that actually when you're looking at those flat components and you're looking at it as if you are the robot system, it's difficult to see the depth. It all looks like one kind of jumbled together like a map. And now you have to interpret that and actually start to understand the depth scenario, and then also to understand, be aware of how big your gripper is. Where can I pick this up without disturbing the rest of the items and damaging them? So this is, again, how AI is being practically applied. And the result of that is a reduction in the setup time of 80%. 80%. And an improvement in the recognition rate of 30%. Still not perfect, but huge improvement. So that means 5 hours down to between 1 and 2 hours to set up. Last example. I guess many of you this morning had breakfast and you might have had some butter and put it on your toast, or you might have had a yogurt. You know, food industry again, but this time AI applied to quality control. Often we hear AI being applied to the maintenance scenario, and so many times I've heard that. It's like, is that all it can do? Look at things and do maintenance? Here we're going to do quality control. Now, one of the big problems for a company that's making food, I can't tell you who this is, otherwise they'll kill me and put me in one of those little packets and seal me up. But basically, one of the issues they have is the only way they can prove that they sealed the container properly is to destroy it. How crazy is that? They take between 1% and 3% of the production off the production line, and then they do a statistical analysis of it by destroying it. That's profit. That's crazy. So why do they do it? Because they're looking to see whether the sealing is done properly. There's nothing underneath the sealing edge. And why do they do that? Because if they didn't, perhaps the quality of the product inside is going down, and then you've got unsatisfied customers. Or if it's a foodstuff, you might even poison somebody because it starts to get bacteria inside and then causing problems for everybody. There's another issue, which is when you start stacking these things up and then you get some leakage come down, and instead of just spoiling one item, you spoil the whole case because the material has come out. Big problems for them. So again, we are using a vision mechanism here, but the challenges are, of course, the surfaces are all different materials and different reflectiveness, and taking a vision view at one angle is not the same as another angle, so it's actually very easy to misread the situation. And basically, the environment also changes, so humidity and temperature can also affect things. And the threshold of acceptance, depending on the material you're actually packaging, can also affect your decision. And there's the limits of traditional technology. We hit them with this because the vision system wasn't fast enough with high-speed flow-through. And also because of the reflection, and we found out that we need to move the camera during the flow-through process, so that we could take the picture from different angles and then eliminate the effects of reflection. So the point is we solved it. Now, why am I finishing on this particular application example? Because I want to go back and say AI is important for the future. It's a tool to support you, but it doesn't solve everything. This needed traditional, good old engineering know-how and mechanical thinking to be able to actually find the real solution for the customer. So, yes, I recognize and we all agree digitalization is superb for the future, but it isn't the key that's going to solve everything. It's not a magic formula for everything. You still need good engineers. You need guys that understand motion, you need guys that understand programming, and you need guys that understand the actual process you're doing. So please bear that in mind. And if you want to look at the future, come and talk to us. We got some other examples we can share with you. And if you want to hear me talk more, you're welcome. But if you all want to rush out for lunch, you better give the guys from ARC the chance to have their panel discussion first.